Hi guys, this is Mansi Varde and I am going to teach you a few things about PSoC for BLE. First of all, what does the term BLE stand for? Bluetooth Low Energy. Okay? But why low energy? What do you think is the problem with the conventional Bluetooth? Like take an example of Bluetooth headphones and your phone. Why do you think we usually prefer wired headphones over the Bluetooth headphones? Expensive? Not really. It is because of high power consumption. You need to charge your headphones as well as your phone every now and then. It consumes a lot of power of your phone, right? So that is why the PSoC 4 chip, that PSoC 4 BLE chip, is a low energy Bluetooth low energy chip. Now we are talking about Bluetooth. But what is Bluetooth? Is it a company? No. Bluetooth is a standard. A standard which you can say is defined by a group of people, and they are known as the SIG, the Special Interest Group. So all the terms that are relating to Bluetooth, that is the standards, the protocols, the client server relationship, how to maintain connection, how to establish connection, how to send the data, what do you think will be the headers involved when you are sending data, all that is defined by this special interest group. And the chip that we are going to use, the PSoC 4 BLE chip, is a new one. New as in it came out in the market right in November 2015. So be content that you're going to use a latest technology. So let's get started. We'll start with the structure of BLE. Before, when you did PSoC, you configured your ADC, your timer. So BLE is also a component such in the PSoC, and we'll learn how to configure it and use it. But first of all, we need to understand some terms that are related to it. We need to learn to configure it, but we can't learn that if we don't understand the terms. So let's get started. First, I'm going to use the example always of a phone and say Bluetooth headphones. So what do you think this is? A phone and a Bluetooth headphones, that is two devices communicating with each other. Okay, so BLE calls them as the central device and the peripheral device. Fine. So in this Bluetooth communication, by Bluetooth I mean BLE, Bluetooth low energy communication, we can have only one central device but multiple peripheral device. Like take an example of your phone. Your phone is the central device and headphones are the peripheral device. Now you can have a pair of headphones and Bluetooth headphones, of course, and your friend also can have Bluetooth headphones, right? When you scan your Bluetooth headphone, when you scan for devices, you'll get to see multiple Bluetooth headphones. So you get to see multiple peripherals. Yes, but your headphone doesn't understand that there are multiple centrals, right? So there can be one central and multiple peripheral, but at a time one central can communicate only with one peripheral. Okay, like you cannot connect to your headphones as well as your friend's headphones at the same time, right? If you want to connect to your friend's headphones, you have to disconnect to your headphones. So what is the communication? Like in the example I told you, if you want to connect to your friend's headphones, you have to disconnect from yours and connect to your friend. If there is another one, you will have to disconnect and then connect again. So at a time, one central can communicate with one peripheral, but there can be one central and multiple peripherals present. This makes the connection as a one-to-one connection. Now this is what happens. Now the structure of BLE is divided in certain layers. Every layer has a specific job to do. So the first layer that we are going to encounter is the gap layer. It is also called as the generic access profile. Every layer has certain roles and responsibilities. Now, the role of the gap layer is to define which device is central and which device is a peripheral. And the responsibility is to establish and maintain a connection. So, the initial phase that happens in our pairing, phone pairing to the headphones, the pairing that happens, just understand that gap layer is behind the pairing. Okay, now let's see how does it actually take place. So we have our peripheral and our central. Peripheral is our Bluetooth headphones and central is our smartphone. The peripheral will advertise and the central will scan. The Bluetooth headphones advertises and the central scans. Once the central gets the peripheral, that is when you click that yes, this is the device whom I want to connect to, then you have two options. One, you can directly initiate pairing. That is what happens in most of our headphones. Once you click on the headphones, the pairing begins directly. And second thing that can happen is the central can ask for more information. Like it says peripheral, give me some more information. Taking an example of your phone and your friend's phone. Like you want to transfer some photos, fine. Then when two phones connect, you just don't pair directly. They ask for some information like the password, right? So that information, so the central says give me some more information. When the central asks for information, it is the duty of the peripheral to provide information, provide a packet. Now what packet the peripheral sends to the central is of no concern. Like the peripheral can send a blank packet too. The peripheral has to send some data, but it can send no data also. Like sometimes it happens, there is a pop-up, you have to enter some password, but you don't enter a password, say yes directly. Communication still take place, right? So the peripheral has to send data, but what data it sends is only controlled by the peripheral. Now after the central gets the data, the central can either read and say yes, the data is through and then pair, or it can say no, this is not the data what I want, and it can just break the pairing. It can just not pair. Okay, so depending on what the peripheral sends, the central will check and act accordingly. So in this pairing and communication, we have two important things, that is authentication and encryption. Let's say when you pair, when your phone is trying to pair with your friend's phone, it asks for some password. The password that it asks for is authentication. Encryption. What do you think is encryption? The data that is being sent can be encrypted or not encrypted. Now what does that mean? Suppose you want to send one particular message to your friend, but you don't want anyone else to read it. Like if it is written in English, obviously someone else can also read it, isn't it? But if you have coded it in some numbers format or somehow, and your friend knows how to decode it, then the data is secured, right? So authentication is checking, asking for password. Encryption is sending coded data. We can have certain modes. So first mode is no authentication and no encryption. Now what will that be? Your Bluetooth headphones and your phone, when you pair them, does your headphones ask for any authentication? No. But there are some cheap Bluetooth headphones also which will not ask for encrypted information either. That means someone else can hack into your device and see what you are playing, which song you are playing. That is possible. But there are some other good ones also. We'll check that. So in this case, you have no authentication, that is, it doesn't ask for a password, and the data that you are sending is open. It can be read by anyone, not just that particular device. Obviously, you will have to hack into it, but still. Second mode will be no authentication and yes encryption. I can say this is the cases with a few good Bluetooth devices, Bluetooth headphones, that they don't ask for a password, but the data that is being transferred is encrypted. That is, which song you are playing, only your Bluetooth device your Bluetooth headphones will understand. No one else will understand. So that is what is encryption. That is, no one can hack into your song and just know what you are playing, okay? Another mode is authentication and encryption. This usually you can take an example of two cell phones being connected to each other. It asks for password, does authentication, and the data that you send is obviously encrypted. Okay, with this knowledge, we say the job of the gap layer is done. It has established a connection and now it knows to maintain it. Let's move on to another layer, which is the GAT layer. Generic Attribute Profile. That is what GAT stands for. Like every layer, this will also have certain role and responsibility. Now, what does attribute mean? Attribute means certain characteristics. So, what do you think will GAT layer be responsible for? The characteristics, that is, if the data is being sent, what is being sent, how it is being sent. So, what song is being sent and how is it being sent is taken care of by the GAT layer. We'll know what exactly it means. Let's first consider the role of the GAT layer. The role of the GAT layer is somewhat difficult to understand. Let's see. We all know about the server and client communication. Its role is to take care of the server and client relationship, what is being sent. Taking an example, when you request, you being the user on Facebook and there is a Facebook server, right? What is a server and what is a client? Like, who is a server and who is a client? The device that has the data is the server, and client is the one who wants to read or write data, that is, who requests for the data. So in our case, who do you think will be the server? Will the peripheral be the server or the central will be the server? Who has the data? Our PSoC board has the data, right? And who wants to read or write? Our phone wants to read or write. So the server is the peripheral and the central is the client. Okay, a bit confusing. Let's see. Let's take an example of Facebook. Suppose you want to post a status on Facebook, right? Now, what status you want to post is your idea, it's your status. You just don't go and say like, yeah, this one or something. It's something that is personal to you. But are you the server because you have the status with you? No, you are the client because you will be requesting the server to write certain information, right? See, now you type the status in Facebook and then you say post. So the client is requesting the server to post, like to do some action. What are we going to do with our app, with our mobile? We are going to say to the PSoC BLE board, do this particular thing. Now we have a find me profile and it has certain alert levels. 3 alert levels: no alert, mid alert and high alert. Through your app you are going to say high alert and then some action is going to be performed on the PSoC BLE. Thus the client is requesting for the server to do some action. Let's move ahead. Responsibility. Responsibility of the GAT layer is packaging and exchanging data. Like I said, if the server client relationship is taken care, which means what data and how it is being sent is taken care by the GAT layer. Let's understand the responsibility in a little detail. Every GAT layer has a service and every service will have a characteristic. Just remember the hierarchy. I'll tell you what it means. The GAT layer has a service and the service has a characteristic. Okay? Now let's take an example of your Bluetooth headphones and phone again. So your characteristics, what will they be? Volume up will be one characteristic, volume down, correct? If you want to play the song, pause the song, play the next song, or play the previous song, all these are characteristics. But these characteristics are divided into certain services. So let's say you have certain service which is with what you want to, regarding to what you want to do with the song. That will be play the song, pause the song, or play the next song, play the previous song. And there will be one service which will take care of the volume information. Thus, what I want to convey is we can have multiple services. One service is regarding the play pause information, and one service is regarding volume. Okay? And we have multiple characteristics. Now, as I said, characteristic was volume up, volume down, play, pause. Okay, so these characteristics are grouped into one particular service, or you can say services has certain characteristics under them. Fine. Now let's move ahead. Now I've said that services has certain characteristics, but that doesn't mean that the characteristics are fixed. Like the volume service has volume up and volume down characteristics. The song service will have play song, pause song, next song, previous song characteristics. But you can have a certain characteristic in the song service itself that says if the volume level rises above 80%, then pause the song. You can have that characteristics. By this, what I mean to say is it isn't necessary that every service will have just the defined characteristics. Any service can have any characteristic. It doesn't have to be specific. So as we see, multiple services can use multiple characteristics. Now, if I just combine all this together, the service and characteristic, what I get is a profile. So what do we have? We have a profile which has certain number of services, and the services have certain characteristic. Now, as I said, for characteristic, that is any characteristic can be used in any service. Similar is the thing for service. Any profile can have any service. Now say your Bluetooth has two services. One was volume service and one was song service. It can have a battery level service too, which might be included in some other profile, or just a service, right? We sends information regarding the battery level of your particular device to the phone, correct? So one particular profile can have any number of services, and the service can have any characteristics. Now we are going to use the find me profile. So the profile name will be find me, and it will have certain services. Service will be the immediate alert service. And what will the characteristic be? Characteristic will be high alert, mid alert, and no alert. Those will be the characteristics. That is how our hierarchy is defined. Okay. Now all these services characteristics are defined by the SIG. They are defined and they are made by the SIG and are readily available to us. Not only the services and characteristics, the profile, a few of the profiles are also made and readily available to us. Like, as I said, the find me profile, one profile is the heart rate monitor profile, one is the battery indicating. So a few profile have been made by SIG. Yes, if you want, you can make your own profile and use the services which are made, services and characteristics both, which are made by the SIG. You can create your own characteristics and services too, but it is a bit of pain. So what we are going to do in the first lab is we'll use the standard profile find me, which is already defined by the SIG, and in the next lab we'll make a custom profile in which we will add our own services and we will say which characteristics which service will have. Okay, let's move forward with understanding the structure. After this, we know that there are services and characteristics. Now there are certain services, or I'll say two services, which is the gap service and the GAT service. Now you will wonder, why is this a service? The gap and GAT are layers, right? They shouldn't be services. The work of the gap service and GAT service is to provide service to gap and GAT layers. What is the job of the gap layer? It is to establish and maintain a connection, right? But don't you think the gap layer will also need certain characteristics, like how it really establishes a connection? It has to search for something. Everything will be defined somewhere. So the gap service provides service to the gap layer, and the GAT service provides service to the GAT layer. The role of GAT layer is to categorize everything and package well. So even that will require a certain number of services and that will require certain characteristics. So this is how the split up works. We have the gap layer at the highest level, then we have the GAT layer. Inside GAT layer we have certain services. After services we have certain characteristics. Okay, so how do you know this as? We have a gap layer, then we have a GAT layer, we have a profile which has certain services, and services have certain characteristics. Now, as I said, any service can be used among any characteristics, and a profile can have any number of services. But how do you think will the device, that is our phone, understand when my phone sends high alert? Which characteristics is pertaining to high alert? How will it understand? You need some identification, you need some code, you need some identification number. So every service and every characteristic has a UUID. What does UUID stand for? It stands for Unique Universal Identification Number. Okay, let's go backward. Identification number, every characteristic will have some number assigned to it, which will be different, right? Unique meaning the volume up profile, the volume up characteristic will have a unique number, the volume down characteristic will have a unique number. Similarly, the pause characteristic will have a unique number, the forward next song characteristic will have a unique number. Correct? Universal. If they are unique, why universal? See, I could say that in my service volume, I have number 1 assigned to volume up and number 2 assigned to volume down. Just an example. And in my play service, that is the song service, I can have number 1 assigned to pause song, number 2 assigned to next song. But if I am going to use the volume service and the pause service together, then there will be a problem, right? Because two characteristics have the same identification number. So that is why they are unique and universal, because every service should be able to understand and every Bluetooth device should be able to understand. Thus we have the universal, that is understood by all, unique pertaining to that particular thing, identification number. With this information, let us get started to making the Find Me app.